Today we're looking at section 10.3 part 2. Our objective today is to find the inverse of a function. Now we're going to look first at this function, f of x equals 2x minus 3. And what I've done is I've done an xy chart where I've picked values for x, plugged them in to the graphing form of the function, and found the y value that goes with it. So, and then I've plotted that function. So notice I have the point 0, 3, or 0, negative 3, 1, negative 1, 2, 1, 3, 3, and 4, 5. I have also put in the line y equals x, which is this red line here. Now notice what happens when I merely switch the x's and the y's. So if I take my in and out chart and make the y's into x's and the x's into y's, so in other words, this point becomes negative 3, 0, this point becomes negative 1, 1, this one becomes 1, 2, etc. Okay, notice what happens. So negative 3, 0 is right here. Negative 1, 1 is right here. 1, 2 is right here. Then 3, 3 is right here. And then 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And I get this line. And notice that this line is the reflection of my function across the red line. So if the red line was a mirror, then I have the mirror image. And the way that I got that was by just switching the x and the y. Okay? And so the yellow line, this yellow line, is the inverse of the green one. And the green one is the inverse of the yellow one. Okay, so we would say that they are inverse functions. Okay, so by definition, the definition of inverse we say the functions f and g are inverse functions if together we have f of g of x, so this composite equals x, and g of f of x equals x. So we use this form to prove that we have inverse functions, okay? And remember, from our graph, inverse functions are mirror images of each other. And really, all that happens is that the x and y's are switched. Okay. Now, not all functions have inverse functions. Only those that pass what we call the horizontal line test. Okay. We say a function has an inverse function if and only if a horizontal line intersects the graph at or in, I should say, in at most 1 point. Okay, so if I had a function whose graph was, say, a parabola, would that function have an inverse? No, because it fails the horizontal line test. If I draw a horizontal line, it meets the graph in 2 spots, so it fails the horizontal line test. If I have the graph of a linear function, so let's say it looks like this, will this one have an inverse function? And yes, it will, because anywhere I put a horizontal line, it goes through no more than 1 point. Okay? Notation. The symbol that we use for a function, so if f of x equals, say, 2x plus 4, which is a linear function, then f inverse of x means the inverse of function f. So this notation means that we're looking for the inverse function. Okay. Well, remember when I graphed the inverse, all I did was switch the x and the y. Well, in order to find the inverse function, so let's say I want the inverse function of 2x plus 4. Okay. Step number 1 is replace f of x with y. Okay. Then the next step, remember when I graphed, all I did was I switched the x's and the y's. Well, that's what you do now. Now you switch the x and the y. So you get x equals 2y plus 4. Now you solve for x. So, I'm sorry, you solve for y. So you want to get y all by itself. So you divide both sides by 4, or subtract 4 from both sides, sorry. And then divide everything by 2. So you get y equals 1/2 x minus 2. So f inverse of x is equal to 1/2 x minus 2. Well, if that's true, then f of g of x has to equal x. Or I should say f of f inverse has to equal x, and f inverse of f of x has to equal x. Okay? So this says in the f function, put f inverse. Okay? So the f function was 2x plus 4. So 2x plus 4, and I'm going to replace x with f inverse, which is this. So that's 2 times 1/2 x minus 2 plus 4 equals x minus 4 plus 4, which equals x. Okay? But it also has to be true the other way. So now I'm going to do f inverse of f of x. Okay, so this one up here was f of f inverse of x. Okay, so now in the inverse function, I am going to replace x with f of x. So it's going to be 1/2 2x plus 4 minus 2. So distribute the 1/2. It's going to be x plus 2 minus 2 equals x. They both come out to x, so that proves that they are inverse functions. Okay? Example 2. Find f inverse of f of x equals 2x minus 6. Okay, this is a linear function, So it does have a inverse. So step number 1, replace f of x with y. Step number 2, switch the x's and the y. So it becomes x equals 2y minus 6. Step 3, solve for y. So add 6 to both sides. Divide everything by 2. So we get y equals 1/2 x plus 3. So f inverse of x is equal to 1/2 x plus 3. Okay? So if f of x is 2x minus 6, then f inverse is 1/2 x plus 3. And remember, when we graph these, they will be mirror images of each other. Okay, so let's try a third example. F of x equals x to the 7th. Okay, and this does have an inverse function, and so I want to find f inverse of x. So step number 1, replace f of x with y. Step 2, switch the x's and the y's. So they just switch places. The next thing is to solve for y. Okay? So I need this to become a 1. So I'm going to multiply this side by 1/7. So I need to multiply this side by 1/7. And I'm multiplying the exponents there. So x to the 1/7 equals y. And so f inverse of x is equal to the 7th root of x. And that is the inverse function.